Hello and welcome back. Let's do a proof. We are given in the diagram points B, C, D, and F are collinear. BC is congruent to FD, angle 1 is congruent to angle 2, and AD is congruent to EC. Prove that AB is congruent to EF. Okay, let's first mark up our diagram to reflect what we were given. This part here, that these 4 points are collinear, means that there is a straight line that contains all 4 of them. So that means this is a straight line. Next, BC is congruent to FD, means that these segments are congruent. Angles 1 and 2 are equal in measure, so we have a little isosceles triangle there. And then AD is congruent to EC is this side and this side. All right, let's write down what we were given. BCDF collinear. We also have BC is congruent to DF. Angle 1 is congruent to angle 2, and AD is congruent to EC. Okay. In order for us to show this side and this side are congruent, we need to know that these larger triangles are congruent. So if we can do side, angle, side, angle to show triangle congruence, we'll be good to go. So we know that this side and this side are congruent, so that's one side. So that's a good check. We know these angles are congruent. Okay, might have a side angle side. But how do we know whether these are congruent? As in this side of that triangle and this side of that triangle. Well, CD is in common, right? And if we did plus CD on both sides of this, that's how we can get that this side is congruent to this side. So let me just note what I said, that if we, starting from this, meaning their lengths are equivalent, plus the same amount on both sides, don't we still have equivalence? Yes, we do, by the addition property of equality. We add the same amount to both sides of an equation, we have an equivalent equation. Okay, so let's write this. BC plus CD is equal to CD plus DF by the addition property of equality. Okay. So don't we have side angle side? We have this side, this angle, and this side being congruent to this side, this angle, and this side. Okay. So by side angle side, we have triangle ABD is congruent to triangle EFC. Side angle side. Okay. But what we need to show is that AB and EF are congruent. That's these sides of the triangles. Well, great. There's a property of congruent triangles that tells us we know that that's true. So we can say AB is congruent to EF by CPCTC, which is corresponding parts of congruent triangles are congruent. And we're done.